Now, this picture for exception handling is probably one of the best graphics I've done as far as the icon graphics go. And notice a guy going down the mountain. That's your regular code going down the mountain trail. And if something goes wrong without a try-catch, that's the man going on the bicycle going off the edge.
So you mean your normal user?
Yeah, there's your normal user. Well, no, that's your user doesn't have any control over it. This is your program going off the edge. So you want to set up a try-catch or a try. So when the program does go off the edge of the cliff, your code will catch itself and then hopefully get back on the trail. And you all are loading the files, so we're going to do a tocrashdemo.java. We're going to do some experimentation with array exceptions, and that's the array exception demo.java. And then we're going to do some logger useIn's frame crash. These are great names, aren't they? And then we have the array exception. And the array exception is when the program asks for something that's beyond the size of the array. So we're going to throw an error when that happens. And you've all seen that array exception.
Pause the movie now by clicking on the double vertical line while you set up these 4 Java programs so you can noodle as we go through this presentation.
Did you all get the tocrash demo going? If you run that, go ahead and run it and then input using integers and tell me what happens. Anybody get a result with the integers? What did you get, Shishu? Didn't get any errors. All right. I love programs like this. That's how I like all my programs to run. Now go in and type in some strings like ONE and 2WTWO. And then write down the error message result. This is really important unless you have a really, really good memory. But look down to see the messages that Java gave you or Eclipse gave you and write those down. And what you want is the exception name, because that's going to determine what kind of catch you're going to catch. So just write down the exception name. And who has an exception for me? What kind of exception do we get when you typed in the strings? Number format exception. And you all know, well, the program is expecting integers. We know it works with that. When it got the string, it says, I don't know what that number format is. Now, restart your program and input one of the inputs as a 0. And then write down the error message. What is it?
You mean the second one?
Oh, the second one. Yeah, write down the second one. That's the one we want.
No infinity.
And what is it?
You can't find that 0.
And what's the exception? What does it say? Error math exception. So your brain, Stephen, tells you, well, you can't divide by 0, but what does Java tell you? That's the exception you want, because that's how Java's thinking. Now open up the code and put a try around the code inside the constructor. And I have up here, I show the try catch block, or the catch block. So notice we're going to catch the number format exception. Now here's a really good programming trick, is use the initials of the exception. So in this case we're using NFE. And as you program more and more, when you see NFE, your brain will just say, oh, that's my number format exception. And in this case, when this happens, we put a message out using the JOption pane to the user, and we say, please enter only integers. Now, this isn't a really good error message because I don't know too many end users that know what an integer is. So you might just say, please use numbers. Keep it very simple for the users. Also, in order to use this JOption pane, you're going to have to use the import statement. So add import jvax.swing.asterisk at the very top of your program. And once you've done that, go back in and run the program again and try that 0 in the second input, and you should get the J option pane to come up. And you've just saved the bicycle from going off the edge of the road into the abyss. As you type this, notice you need to put your try and your curly braces around the actual code that's going to run. That's your safety net. And if anything goes wrong and the bicyclist drives off the edge of the cliff, in this case the user types in a 0, then we do the catch, and the catch is how we get the bicyclist back on the trail. So if you have error messages, put that try around your code first, and then you have the catch to follow up on. Now this only solved our input with 0, so let's solve our input with our arithmetic exception. This is dividing by 0. So you have your try around the code inside the constructor. Now add this catch block after the one that you just did. And this is going to be our arithmetic exception. And again, we use the initials AE for the arithmetic exception. Now, if you open up the array exception demo.java, and when you run this program, input the number 5 or less. And then input the number greater than 5. And then input a string instead of an integer. And each time that you get an error, write down the error message results. Now this is kind of like bounds testing. So when you test a program, you should be testing for numbers within bounds and out of bounds, as well as something odd that a user could type in. Because if you don't test for it, I can tell you the very first user will. The other thing is to write down the error results, because you can already see how that affects which exception you use. Now this is a really nice technique called a trace, and what the trace will do is it will show you the stack or what's in the memory. So find the fill array method, and inside the fill array method put a try clause, so it's try and the 2 curly braces around the parse int and the for loop. So you're gonna put a safety net around the parse int and the for loop. And then we're going to use the superclass exception to catch everything. So this is going to show us all the exceptions that are happening. So notice the catchphrase here, we use just exception, E, and that's all exceptions. We're not doing a specific exception like we did in the last 2 examples. And the output is we just know an error happened, and we're telling the user or ourselves that we are in the catch block. And then here's the good part. We print out the stack trace. So the first thing we do is output a label saying here's the stack trace, and then we use the E exception object and we print out the stack trace. It's a method that comes with the exceptions. And when you run this code, and tell me what comes out of it. So let's try a try catch on the null pointer error. And if you'll run the login user's frame crash. And notice how the program crashes because the array hasn't been initialized. What's the exception message that you get when you run the program? Null pointer exception, absolutely. And you'll see a lot of null pointer exception errors if you program with Java. And when you get the null pointer exception, it means that you declared an object, but you didn't allocate it. You didn't use a new to initialize it with data or make it into an object. This is a very, very common error. And often you just have to go through your code and look where everything was declared and then find the matching places where it's initialized. So here's how you trap the null pointer error. So again, you put your safety net around, so put your try with your curly braces around the code that sets the user passwords. And I show it here on screen. So there's your try, and then there's the users in the array. And then for the catch, I look for the null pointer exception, and I name it NPE. So it's NPE of type null pointer exception. And then I print out a nice friendly message that says you need to initialize the array with an exclamation mark. Now notice the reverse indenting on the try catch. And this is beginning to gain popularity. Originally it came from Sun Microsystems, and when there's code with lots of try catches, it gets real busy to read because everything's indented normally. If you do the reverse indenting and indent your tries 3 spaces, and then your regular code stays in line with your other stuff, it kind of de-emphasizes the try catch. It also points out that it's like exceptional code. So again, the try and the catch code is indented 3 spaces. Everything else stays where it is in the normal scheme of things. And now when you run the program, it should give you the error message. Now here's how you give the program a second chance. So we're going to look at the array exception demo throw, and then look at these 3 additions that are included in the code. First, I set up a while loop so the user can retry things. And then where the try catch is used, the methods throw the exceptions back to the caller. And the third addition was I added a finally block. Now, in a try catch, finally always runs. So it's a good way to clean up and releasing resources when you're done. Just remember, when you have a finally block, it's going to run if the exception happens or not. It's always going to run. So do you see those 3 pieces in this code? And if you run it, you can see how it loops back, especially if you put a breakpoint and trace your program as it goes through in the breakpoint. So where would you put a breakpoint on this?